Hi everyone, welcome back to Coding Fab. Today we're diving into Matplotlib, one of the most popular Python libraries for data visualization. Whether you're working with line charts, bar graphs, or scatter plots, Matplotlib gives you the tools to bring your data to life. In this video, we'll start by explaining what Matplotlib is, then explore its core components, and finally walk through how to create your first basic plot. We'll also cover different chart types, layout settings, and ways to customize your plot with titles, labels, and grids. All right, let's get started. 1. What is Matplotlib? Imagine this. You've got some data. Maybe it's how many steps you walk each day, your weekly expenses, or the temperature each month. Wouldn't it be great to see that data as a line graph, bar chart, or pie chart instead of just staring at numbers? That's where Matplotlib comes in. 2. Core components. There are 4 core components of Matplotlib: pie plot, figure, axis, and axis. These are the building blocks that help you create all types of charts in Matplotlib. First, pie plot. It's a high-level interface that makes plotting easy and quick. It works like a command center that automatically manages figures and axes for you. They are created by functions like plt_figure or plt_subplots. Figure is the entire canvas or window that contains all your plots. A single figure can hold multiple axes. Axis is the actual chart area where you draw your data. It contains the plot lines, bars, x-axis and y-axis, labels, title, ticks, and grid lines. Axis refers to the x-axis and y-axis within each axis. It controls tick positions and labels, axis limits, scaling, and formatting. 3. Basic plot. Let's check the basic flow of using Matplotlib. First of all, import Matplotlib. This imports Matplotlib and specifically the pyplot module. Pyplot is often named as PLT to make it shorter and easier to write later. Next, give it some data. Imagine each number pair as a dot on a graph, and Matplotlib will connect those dots with a line. Next, tell it what kind of chart you want. There are so many options such as line graphs, pie charts, histograms, and more. In this case, it tells Matplotlib to draw a line using the X and Y data. Then customize the chart with adding titles, labels, and colors to make it beautiful. Finally, display or save it. The show method displays the figure in a window or in a notebook. The savefig method allows you to save the current figure as a file. It supports PNG, JPEG, PDF, SVG, and more. So this is the basic flow of using Matplotlib. It's easy to use and very flexible. 4. Plot types. These are the common 8 plot types. First of all, plot, as we have seen on the previous page. It creates a line graph, great for showing trends over time or comparing two variables. Let's check it with the example. First, import Matplotlib and specifically the pyplot module as PLT. Then use plot method. It tells Matplotlib to draw a line using the X and Y data. It automatically connects the dots into a smooth line. The title method adds a title at the top of your graph. The show method displays the graph in a window or in a Jupyter notebook if you're using one. Finally, you get a line graph with x-axis and y-axis values, and the title line graph example on the top. Next, bar method. It draws a vertical bar chart, perfect for comparing values between categories like sales per month. Let's say we have 2 lists. Categories contains the names of the groups you want to compare, A, B, and C. Values contains the numbers for each category, 10 for A, 15 for B, and 7 for C. Then give them to the bar method. It draws a vertical bar chart. Each bar will represent a category A, B, C on the x-axis. The height of each bar comes from the corresponding value on the y-axis, so it's perfect for comparing values between categories. Next, bar H. It draws a horizontal bar chart, same as bar but flipped. Next, histogram method. It creates a histogram, shows the distribution of data. Great for statistics. Let's say you have a list of numbers. Each number appears multiple times. 1 appears once, 2 appears twice, 3 appears 3 times, 4 appears 4 times, 5 appears 5 times. You're going to visualize how often each number appears using a histogram. The histogram method draws a histogram from your data. A histogram groups values into bins, which are like value ranges, and shows how many data points fall into each bin. Bins 5 means it will divide the data into 5 equal width ranges and count how many values fall into each range. And the bar height shows how many numbers are in each bin. So histogram can be used to understand how data is spread out, and to spot patterns like, is the data centered around a certain number? Are there spikes or gaps? Is the distribution balanced or skewed? Next, scatter method. It creates a scatter plot, ideal for visualizing relationships between two sets of data. Let's say you have 2 lists. These 2 lists are data points. Each pair is a coordinate for 1 point on the graph. So you have 5 points in total. In this graph, each point is shown as a dot on the graph, no lines connecting them. It's used to visualize relationships or patterns between 2 sets of data. You can use this when you find patterns or correlations. For example, are the points going upward? That might mean a positive trend. Are they random or all over the place? That might mean no correlation. Next, pie method. It creates a pie chart good for showing proportions or percentages. Let's say you have a value and label pair. Values is a list of numbers representing the size of each slice of the pie. Labels is a list of names for each slice, like category names. So A gets 40 units, B gets 30, C gets 20, D gets 10. Together they add up to 100, which is perfect for a pie chart that shows percentages. The pie method draws a pie chart using the values and labels. Each slice is proportional to the value it represents. Labels argument get labels list, then displays A, B, C, D on each slice. The auto PCT means automatically shows the percentage of each slice with 1 decimal place. The first percent sign means starts the format code. It tells Python you're about to insert a value. The first one means minimum width. It's optional and often ignored in pie charts. Point 1 means 1 digit after the decimal point. F means floating point. For example, you can change it like this. After running the code, you'll see a big slice labeled A, a slightly smaller slice B, then C, and a small slice D. Next, box plot. It creates a box and whisker plot which shows median, quartiles, and outliers in your data. Let's say you have a data list made of numbers. A box plot helps you see how your data is spread out, especially what's typical, what's high or low, and if anything is unusually far from the rest. It automatically calculates and shows 6 key parts of your data. Minimum is the lowest value, excluding outliers. Q1, first quartile, is the 25% of the data. It's below this point. Q2 is the middle value. Q3, third quartile, is the 75% of the data. It's below this point. Maximum is the highest value, excluding outliers. So the box is from Q1 to Q3. Whiskers extending to the minimum and maximum. And if there are any outliers, they are shown as dots. Next, image show. It displays image data like heat maps, pixel maps, or 2D arrays as an image. Let's say you have a 5x5 matrix created by the NumPy library filled with random numbers between 0 and 1. If you don't know NumPy, check out our NumPy videos. The image show method displays the matrix as an image, where each number is turned into a color. CMap Viridis is a color map. It gives your plot a nice gradient from purple to yellow. You can try others like plasma, hot, cool, and so on. Each number in the matrix becomes a colorful square. 5. Multiple plots. Let's check how to create multiple plots step by step. First, the figure method. It creates a new blank canvas to draw on. You usually use this when you want to create multiple charts separately. If you don't call PLT figure, Matplotlib will automatically create one for you. But when you want full control, like making multiple charts, you should use this. Next, subplots method. It creates multiple plots inside one figure, returns two things, a figure and axis. Let's check the examples. First, single plot. The first line creates a figure and one axis object. As we learned in the previous core components page, axis is the actual chart area in the figure where you draw your data. Now you can customize each chart using Ax. The second line is, instead of using PLT plot, you're telling that specific ax to draw the line. So you can customize each axis separately. Second, multiple plots. Let's say you want to create two plots in one figure. The first line means one row and two columns of plots. Fig is the entire figure or canvas. Axis is a list of axis objects, one for each plot. Axis 0 is the first plot. Axis 1 is the second plot. Set title method allow you to set the title separately. Then you can see the figure with two charts side by side. The left chart shows a line going down with the title first plot. The right chart shows a line going up with the title second plot. If you want to create a 2D array like 2x2 grid, you can write like this. First, declare two rows and two columns here, and accesses each subplot by its row and column position. Then you can see 2x2 plots. As shown here, you can create different types of graphs. So it's useful when you can compare multiple datasets easily. Also, you can create dashboards, multi-view visualizations, or report-ready layouts. Next, subplot method. It helps you create multiple plots inside one figure. You place plots in a grid layout. It's great for quick side-by-side or stacked comparisons. Let's say you want to create a 2x1 matrix. The first line means two rows, one column, and the plot index is 1. So the plot index number for the second plot is 2. You have to use rows, calls, plot index format every time. Then you'll see two plots stacked vertically in one figure. What is the difference between PLT subplot and PLT subplots? This is the difference between PLT subplot and PLT subplots. Subplots is cleaner and more readable, especially when you want multiple plots. Also easier for applying layout settings. Next, tight layout. When using multiple plots, sometimes it becomes necessary to adjust the layout. The tight layout automatically adjusts spacing between subplots or elements so they don't overlap. For example, the left one doesn't include the tight layout and overlap. The right one is improved with the tight layout. Next, fig size. Sometimes you might want to adjust the size of the entire graph. That's when you can use fig size. Only you need to do is just set the size of the entire figure in inches. You can use it for both PLT figure and PLT subplots. Let's check the example. Let's say you have a bigger plot on the screen and want to adjust the size. By adjusting it with fig size, now it's balanced. Six, plot decoration. You can customize the plot with these methods. First, title. As we have seen, the title method is used to add a title above your plot, so everyone can know what the graph is about. Next, X and Y labels. They label the X-axis and Y-axis to explain what they represent respectively. Next, legend. It adds a legend, a small box that tells you which line or bar represents what. It's super important when you have multiple lines or data sets in one plot. Next, grid. It adds a grid to your plot, making it easier to read values. You can even control the grid style like this. Common grid style options are line style, color, line width, and axis. 7. Axis control. You can control axes with these methods. First, PLT axis. It lets you control the axis limits and scaling of the plot, as shown here. You can set minimum and maximum X values as well as minimum and maximum Y values. Next, X limit and Y limit. You can set the limits for only the X-axis or Y-axis, minimum and maximum values for each. It's useful when you want to zoom in or focus on a specific range of values. Next, X ticks and Y ticks. It lets you customize the tick marks on the X or Y axis. Mainly, there are 3 ways to customize ticks. First, showing only the specific ticks. In this case, Y-axis only show 10, 20, and 30. 25 is not displayed. The second example is changing the labels. You can replace the numbers with custom text like this. Lastly, rotate the tick labels. Let's say you have X, Y in a label list, and want to rotate only the X ticks because the label text is too long. The way to change the tick angle is easy, just set the rotation. Then you can rotate labels and improve readability. This is useful for long text or dates. That's it for today's video on this topic. We explored what Matplotlib is, learned about its core components like figure and axis, and saw how to create different types of plots using simple Python code. Let's quickly review all the learnings. 1. What is Matplotlib? It's a powerful Python library used for creating visualizations. 2. Core components. Highlighted the 4 key elements. PyPlot is the high-level plotting module that can manage figure and axis. Figure is the full canvas. Axis is the individual plot area. Axis is the X and Y axis inside each plot. 3. Basic plot. We learned the essential steps of creating charts, including importing a library, preparing data, choosing a plot type, and showing the graph. 4. Chart types. Learned common plot types like line charts, bar graphs, scatter plots, pie charts, and more. 5. Multiple plots. Covered methods for handling more than one chart in a figure, and also how to adjust the layout. 6. Plot decoration. In this section, we learned to add titles, labels, legends, and grids, which are important for making plots understandable. 7. Axis control. Covered how to manage axis limits and ticks. This helps customize the appearance and focus of your plot. These are the foundational tools you'll use again and again in data science, machine learning, and beyond. We encourage you to try plotting your own data. Whether it's your daily expenses, a small data set from a school project, or just some random numbers for practice, the best way to get comfortable is to start experimenting. Keep playing with different chart types and customizations. You'll get the hang of it faster than you think. Okay, Thanks for watching today's lesson on coding Fab. I hope you found these tips useful and feel more confident. Remember, practice makes perfect, so try using these tips in your project. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more Fab coding lessons. Until next time, keep practicing and stay Fab.